This video segment will be about matter and its different classifications. So, the first thing that we want to do is we want to review what is matter. Okay? Matter is anything that has mass and takes up space. So if it has mass, that means it weighs something. And if it takes up space, then it has volume. Okay? So it's anything that has mass and takes up space. Now, matter is made up of these tiny particles that we call atoms. Okay? This should be familiar to you from class and also from physical science. So, matter, anything that has mass and takes up space, made up of small little things called matter, or of atoms. So, you can break it down into two things, pure substances and mixtures. We're going to start with pure substances. Pure substances are things that are 100% one thing only. Okay? They are only one thing. So, for example, an element. An element is on the periodic table, and it is atoms of one kind. So, atoms of one kind. For example, you could have calcium, you could have carbon, you could have silver, which is Ag, excuse me, not Au. All of these are examples of elements. Okay, you find them on the periodic table. Notice C and A. This is a lowercase a. The first letter in an element is always capital. The second letter is always lowercase. But an element is on the periodic table of elements, which is why it's called that. So, if we look at a compound is chemically bonded elements. So, for example, CO2. CO2, or carbon dioxide, has two capital letters, a capital C and a capital O. This means that it includes two different elements. A capital C is the symbol for carbon. A capital O is the symbol for oxygen. So CO2 is when carbon and oxygen are bonded together. Now, the reason why this is called a pure substance is if I have a box that only has CO2 in it, then that's pure. It's purely carbon dioxide. If I have a box that only has Ca in it, if it only has calcium, then that is purely calcium. So it's 100% one thing only. If we look at a mixture is when elements and compounds have been physically combined. Notice that I use the word physically combined. That's because they are not chemically reacting. Okay? They're only physically combined. Now, you can have two different types of mixtures. You can have homogeneous and heterogeneous. Now, the prefix homo here means same, and the prefix hetero means different. And that's because a homogeneous mixture looks the same. All of the things are mixed together, but it all is uniform, or it looks the same. A heterogeneous mixture has several things in it, but they look different. So, for example, Kool-Aid has several ingredients. It has the powder, and it has the water and the sugar, but when it's all mixed together, it all looks the same. That would be homogeneous. However, trail mix would be heterogeneous. trail mix has peanuts and raisins and M&Ms, and even though they're all mixed together in the bag, you can still see the different components. You can separate them, okay? One special type of a homogeneous mixture is called an alloy. An alloy is when two or more metals have been mixed. Okay, so for an example, we could have bronze, we'd have bronze, 10-karat gold. Okay, if you ever have had a 10-karat gold and wondered why do they include the 10-karat part, it's because it includes not just gold, but oftentimes copper or something like that to strengthen it. So an alloy is a particular type of homogeneous mixture. Okay, a homogeneous mixture is also called a solution. All of these vocabulary words are things that you need to continue to review. There are examples on eClass and on the internet of figuring out, okay, is it an element? Is it a compound? Is it a homogeneous mixture or a heterogeneous mixture? Let's look at some examples. If I have the following items, CO2, pepperoni, pizza, and oil and water, and sugar water. I want to be able to classify these things as being either an element, a compound, a homogeneous mixture, or a heterogeneous mixture. If I look at carbon, C, it's all by itself, only one capital letter. It is on the periodic table, so this would be an element. CO2, which is actually a bad example because we already did that one. Let's choose something different here. Let's choose NH3. I have two capital letters. The presence of two capital letters tells me that I have two elements that have been bonded together. And that is the very definition of a compound. Pepperoni pizza. Pepperoni pizza has cheese and pepperonis and the crust and the sauce, and even though it's got a bunch of different components, I can tell the difference between it all. So that would be an example of heterogeneous. I think I spelled that wrong. Heterogeneous. Oil and water. If I mix oil and water together, they do not stay mixed very long. Even if they're in the same container, we know that oil will end up at the top and water will be at the bottom. And so I can separate them. I can see the difference. So it's heterogeneous. If I have sugar water, though, I know that when sugar dissolves in water, I can't see it anymore. And if I can no longer see the individual components of the mixture, then that means it is homogeneous. Homogeneous. We can also call it a solution. Homogeneous or solution. So you should continue to practice these at home.